My name is Justin Lee. I'm currently the senior software engineer, or a senior software engineer for Squarespace. I've been doing Java since '96, but more importantly for our purposes this morning, I am the implementer, or the original, I guess someone else does it now, of WebSocket support in Glassfish, Glassfish and Grizzly. So if you use the Grizzly WebSocket API, it's my fault, for better or for worse. So like I said, I'm at Squarespace now, but I'm also on the WebSocket JSR expert group, helping out with that. So that is without too much whatever. I want to go briefly over why WebSockets without going too deeply into it, because there's like 1,000 WebSocket sessions, so hopefully most of us are familiar with it. But for those who aren't, I did want to at least cover some of the motivations behind it, so it all makes sense. And essentially, it's a response to HTML and HTTP. They've been around forever, and we've kind of shoehorned a whole raft of new types of applications on top of it that is never really intended to do. There are certain costs that you pay for doing things even like Ajax and Comet and whatnot on top of HTTP. So WebSockets attempts to address that. HTTP is also stateless because, as you know, you make one request, it comes back, and then the server's done with you. You get a session data, and you can put stuff in there, but you still have to manage that yourself. And it's gotten increasingly complex, our applications have, as the time goes by, and HTTP hasn't quite kept up with everything we want to do. So people started looking at alternatives. It is, I don't know if I have it on this slide or not. WebSockets is built on top of HTTP, so your web servers, your routers, your gateways, it'll all look like HTTP traffic coming in. But once it makes it through all the routers to the servers, it stops being HTTP. When people talk about WebSockets, there's actually a number of different components to it. There is a wire protocol, which is the actual bits and bytes on the wire, and that's handled by the IETF, and that was recently ratified this summer as a formal specification after several years of development. But there's also the client side, as for at least in the browser, the W3C is managing that specification. I don't think it's final yet, but it's stable enough that most of the browsers support it, and we'll see in a second here. So probably any browser you care about now, unless you're an IE fan, will have support for it. So there's the JavaScript API, and then GSR 356 is an attempt to standardize that. And I was talking to Greg Wilkins, who was also on the expert group last night, and the thing I like about this now, I actually pushed for standardization for a year or two when I was still at Oracle. Because one thing that I didn't want to have happen is if you ever do Comet development, and you have to figure out what platform you want to work on. Are you working on Jetty, or you're working on Tomcat, you're working on whatever. And your Comet application then has to change depending on what you're working on. And I really wanted to get WebSockets standardized from an EE perspective, so you can at least build your application once and not have to redo it for everything. Right, so it piggybacks on top of HTTP, like I mentioned. It uses the connection mechanism in the header. If you're familiar with HTTP header negotiation, there's a couple headers you can send to ask for an upgrade, and then the server can either upgrade it or reject it if it doesn't know how to handle it. But so what WebSockets gives us is it gives us an asynchronous bidirectional communication channel. It's full duplex. So once it's open, you can keep it open for as long as you want, and both sides are free to send messages back and forth. It is not request response anymore. So like your traditional servlet model it's not quite the same, because you may not ever have a response when your request goes out. And similarly, you may get a response having never sent something out asking for it. It does support extensions, more or less. It's not as well baked. They're still kind of working out how some of that's supposed to work. But the most common extensions they're talking about right now, there is active discussion on multiplexing in the protocol. Right now, if you have multiple things going on in your web browser and you want to open up a WebSocket connection, unless you build in multiplexing yourself, each connection would be its own connection to the server, which is mostly kind of okay, but of course it doesn't scale because you might have 8 million connections coming in at once. So multiplexing will help that. And then there's compression. There's actually compression in this RFC as it is now, and it's I think it's per message, and they're looking at per frame compression, which might matter to some of you guys. But the compression scheme is probably going to change in what the standard compression is. But that should hopefully mostly matter to people like me who are trying to implement things like that. And it does have support for sub-protocols. So if you're writing an application, you can say, I want to open a WebSocket connection, but I want, I need the payload to look like this. So you specify, I want whatever your protocol might be, whether it's chat or email or Kazing, for example, has JMS built on top of WebSocket, so you can tunnel all your JMS stuff through routers and whatnot without having to open yet another port. And WebSockets has support for saying, this is what I want to do. Okay, so on the client, like I said, most browsers now support it, so if you want to start playing with it, chances are your browser is going to be okay. IE 9 does not have it. 10, I have yes, because it is Microsoft, and they have not traditionally played nice with most, whether it's CSS or whatever. But the 9 and 10 teams do seem to be a lot more receptive. They figured out it's like we don't own 80% of the market now, so we have to actually care what our users are telling us. And they've actually seemed to be really, really receptive and proactive about making sure they're interoperable with stuff. Firefox and Chrome have had it forever, since version 14. I don't even know what version of Chrome I'm on anymore. I think it's 23 because it just updates. So chances are if you have Chrome, it's working. Safari's had it since 6. If in the mobile world, it gets a little spottier because those browsers are kind of on their own timeline. But Firefox and Chrome both have it on Android. The native one does not yet, which I don't quite get because I would expect the native to be some form of Chrome. And then on all your iThings, it's getting there. 6 might have it. I haven't looked at it since 6 came out because I just realized it came out like a month ago. So, not all your clients need to be browsers, and that's the one thing I like about WebSockets is, at least in the protocol level, it's not tied to a web browser environment. So you can actually write clients in Java. The Grizzly API actually has a WebSocket client. So if you want to write clients for whatever reason, and there are a number of reasons you might want to do that. So the other end might not be a browser. It might not even be Java. So on the client, you have a couple of options. You can roll your own. There's a project called Atmosphere that we'll talk a little bit about later. If you haven't seen that, it's actually really, really nice. It is kind of an abstraction layer so that whether you're writing a common application or now WebSockets, you can write to the Atmosphere API on the server and the client, and it figures out magically what your deployment platform is, and then if you deploy on Grizzly, it'll figure that out and wire it up. But your application doesn't change because Atmosphere takes care of all those changes for you. And then, of course, Socket.io, if you're a JavaScript guy, they do all sorts of fun stuff in Socket.io. On the server-side options, there's actually, this isn't even all of them. This is just kind of a brief spectrum. Autobahn is actually kind of nice. It's Python. Autobahn is notable. They have a very robust, very thorough testing suite. So if you need to validate your WebSocket implementation, Autobahn will hammer at it and tell you what's wrong. WebSocket is out there. I don't know a whole lot about it, but it's one of the earlier ones that I remember seeing pop up. Kazing, of course, has it. They have their WebSocket gateway. It's in Netty, Jetty, Glassfish, and Grizzly, of course. And I mentioned Websphere. Webbit is built by one of the expert group members, and I don't think it's actually in Java, even though the guy who wrote it is typically a Java guy. I forget what it's written in, but we are going to focus on these today because these are the ones that I know, and we can't cover everything. So we're going to go over these and just kind of see. We're going to take a look at each of their APIs and how they differ, and then we're going to end up looking at what the current state of the JSR API is. And we did just go into early draft review, which means there's Java docs and a PDF and a spec. So if you're one to figure out what it is, now's the time to download it and look at it, because the API is still in flux. But obviously, as the process goes along, the chances of you getting something tweaked because you don't like it becomes less and less. But that is out there. So, and then after that, I want to talk a little bit about Speedy. When I first saw that, I was like, oh, it's Spidey. And I know it's not Spidey, but I like to call it Spidey because it's more fun. But it is Speedy is the official thing. So if I call it Spidey, I'm not a total idiot, partial one. I just like to call it Speedy because it just sounds more fun. And then HTTP 2.0, and those are both broader views of what basically the WebSocket protocol was meant to fix. So, Grizzly and Glassfish. This is the one that I built, so it's the one that I know the most. I'm slightly biased toward it, but I try not to be. But here, these are the main components you need to know. Have you even done comment development on top of Glassfish or Grizzly? When I built this, I don't like doing clean room stuff because you never know what makes sense out in the world, but in your head. So I based my API on how the comment engine works. So if you've done comment development, a lot of these will look familiar. But there is a WebSocket engine, which is exactly what it sounds like. There's a WebSocket application, which is really where like all your application logic would exist. There's a WebSocket, which would be the actual connection that represents an endpoint on one side or the other. And then of course there's a client. And I added the concept of a WebSocket listener because it sounded like a good idea at the time, but as I worked more with the API and built my own applications and whatnot, the listener made less and less sense, but it has certain possibilities that you might want to use. But I think the API had evolved to the point where it was a little bit redundant, was my problem with it. And if you're on Glassfish, the last thing you'll need to get your application going is a servlet. And that's not strictly true anymore because another team somewhere in the bowels of Oracle is actually starting to work implementing WebSockets in the container in a more Java EE friendly environment. So there are actually deployment annotations now that we'll see. But all my examples, if you go, I have stuff up on GitHub. All my examples use a servlet because that's how it worked when I wrote that code 2 years ago. So what does an application look like? This is the interface, and there's a couple of methods. Not all these you need to care about, but these are the potential ones. Create WebSocket. If you want, you can override it. And for example, when I would write demos, I would subclass create WebSocket, and I would return some sort of subclass of WebSocket, and then you can put on things like if you're doing, for example, like a chat, because everyone writes chat examples. That's where you would store like the username and password for that particular endpoint. Any sort of state that you want to save about that particular connection is how you do that. There's onClose and onConnect, and those are just callback methods. So whenever WebSocket connection comes in and you want to do something when it connects, add it to a session or validate this or that or whatever, you would override onConnect and handle that. The one you actually absolutely have to is called isApplicationRequest, and it's admittedly a very awkwardly named method. But it's basically where you would check the URI coming in saying, is this something that this application is intended to process or not? And if you return true, then the WebSocket handshake and such take off, and it'll load up your application. The handshake you can subclass if you want. Most of you probably will not want to do that unless you really know the protocol, because that's when it starts doing, there's bit shifting and masking and weird things to validate that the request coming in actually is a WebSocket connection. Most of the time you won't want to do that, but some people want to be able to, for example, send back cookies or session IDs or whatever back to the remote client, whatever it might happen to be. And you would do that in the handshake, because that's where that response gets sent back. And then onError is a handler if you want to do, if you want to check something when an error occurs, of course. So this is the interface in Grizzly 2. I had a little bit of help in building this interface, but it looks basically the same if you do Grizzly 1.9. So there are send methods, there's pings and pongs as part of the protocol. Those I don't know that a lot of people really care about. Most of them are used for like heartbeats and make sure that are you still there? Are you still there? But there are certain spec requirements in an implementation about pings and pongs and responses. But you can hook into that if you want. You can stream data back. This is a little lower level than we'll see once we get to the JSR API. When you send WebSocket data on the protocol, it will break it up into frames. and those frame size will vary, and that frame size can actually be changed for you. Like an intermediary can come along and say, you're sending this 4 meg chunk, but I really only want to deal with 128K at a time. So it will actually fragment your message for you. And when it gets to the other end, it will come back as fragments. So that's what those methods are. And there's a bit that gets set when it's the last framing that comes in. It's a little lower level than I would probably build it now, but again, it made sense at the time. And we'll see some better APIs going on. And then is connected, that does exactly what it sounds like. And then here we have actual callbacks on the WebSocket, and these callbacks are unlike the callbacks on the application, which happen for anything that happens with your conversation. These callbacks deal specifically with this particular endpoint. So when you get a message, on message will come, and there's a couple of variations, string and a byte array. You get an on fragment if you come back. Like I said, if something had fragmented your message, it'll show up in on fragment instead of on message. On close, if you want to handle detecting the other end drops off for whatever reason, and you want to clean up database connections or open files or whatever, you would do that. On ping, on pong are there in case you want to be able to hook into that. And then you can add WebSocket listeners and remove listeners if you want. And we'll see that API. It actually looks a lot like the WebSocket itself, which is why it's a little redundant, but it's still there. So it's not quite as bad as it looks like, but this is how you would set up. If you're doing straight Grizzly code, you would create a WebSocket server, you'd give it an address and a port, and then implement these two particular whatevers. This is actually from a unit test, which is I pulled out of the actual source code out of Grizzly because it's small enough to at least give you a feel for kind of what's going on. This is actually just part of basically a ping test. And in this case, I'm waiting whenever I send a ping from the client, I'm waiting, and then there'll be a latch countdown so I can check it and say, yes, that ping arrived, and we did appropriately call on ping, and then everything's done. And then the same thing down at the bottom, you can see the client, we create one, and we do an on pong, because whenever you send a ping to the server, it's required to return a pong back to you. And sometimes you can actually get a pong without ever having sent a ping, which is a little weird. But it made sense for the working group, so there it is. So then you'd start it, you'd connect. Whenever you create a client, it doesn't automatically connect. You have to call connect, and you can give it a timeout. It's like, I only want to wait at most 5 seconds, otherwise bail, and let's do this. And then, of course, there's your send ping. Ping payloads are all binary. And in this case, we're doing UTF-8 encoding for that. So now Tomcat. The Tomcat WebSocket kind of surprised me when it landed. I was hoping to actually help out with that, but it showed up and it's like, oh, someone already did it. It was primarily Tomcat 7 option when it landed. And I forget, it was Mark, I think, from the Tomcat team. It was actually, they were hoping that it would be motivation for people to upgrade to 7 and get off 6 so they can quit supporting things. And then someone went and backported it to 6. So he was simultaneously, grateful that someone did that and a little bummed because he was really hoping to use that to move people along. So that didn't work out. The main concepts here are it's called stream inbound and message inbound, and then WS outbound, which basically input streams, output streams, and they also have a servlet-based approach. In the case of Grizzly, you only really need the servlet, so it comes up, and then you can say you can register your WebSocket application with the engine. In their case, they actually just extend servlet, which is a subclass of HTTP servlet, but it handles all the stuff for you. And that's their entry into how you get your WebSocket application to work in Tomcat. We'll see a little bit about that. So the message inbound extends stream inbound, of course, and then they have 2 callbacks on binary data and on text data. And they expose that incoming data using standard Java I/O interfaces. And then the 2 binary message byte buffer and text message with the char buffer. And those are callbacks, and that whenever it comes in, you'll have to subclass that and then deal with whatever the message comes in. I did byte arrays when I did Grizzly because in part because I had to have the same API with Grizzly 1.9 to try and keep some sort of fidelity between the 2. The byte buffer and char buffer, most people don't work with them. Unless you do a lot of NIO work, you may not have ever even heard of byte buffer or char buffer. They're actually a lot nicer than my byte array option because they can actually wrap a byte array and return it to you without byte array copying. In Grizzly, we do a lot of byte array copying because we don't use this approach. So this is actually a bit nicer memory-wise and speed-wise than my approach. So WS Outbound is basically the output stream. It's the same. It's a very familiar interface. And then you have your byte buffers, you have your char buffers to send. You can see you can send a pong, but you can't send a ping with this, which kind of hides off part of the spec. I'm not sure it really matters that much, but it's interesting. It's not quite as symmetrical as you'd expect. And then you the same basic, very kind of obvious methods. You can actually write a single char, which is a little weird. But if you want, that's what you do. So here's what their servlet looks like. They have a class a method you can override, create WebSocket inbound. And that's where a lot of your business logic would reside for your application. And it is a servlet, so there's a do get if you wanted to override it. It doesn't make a whole lot of sense if you're trying to do WebSockets because once your application gets it, there is no do get, there's no post, there's no head, because it's not HTTP, so all your verbs make no sense in a WebSocket application. But you can select your sub-protocol if you want. Protocol negotiation in WebSockets is it's very loose and fluid. If a WebSocket request comes in and says, I want this sub-protocol, the server actually responds with, you requested any of these 4 sub-protocols, but I don't support any of them. Sorry. And the server can do that, and then it's valid. And then the client has to decide whether or not it still wants to do what it wants to do. So here you can select which sub-protocol you want to send back. And you can verify the origin. There's, without getting too low level, there's certain origin verification that can go on to help protect against, cross-site scripting, all that sort of stuff. So you can do that in there. Right. So this is what an echo server would look like. They subclass servlet. They create their message inbound, and it's simply an echo. Those 2 really big numbers are buffer sizes. It's from their code, and it's just a really big number for no real apparent reason. But this is what it would actually look like. It's right. It's the buffer size because they'll buffer stuff on the server for you. So you can set the buffer size for your text data or binary data. Here they have the callbacks on binary message. You get your outbound and you write your binary message in text. Pretty straightforward. It's just an echo thing, but that's what it would look like. Now Jetty is also WebSocket servlet based. If you go to their wiki page, they're a little hand wavy about it. It's like no one should ever use this stuff. Use a framework. Which I guess is okay, but it's a little bit like never ever use servlet directly. You should use something else that abstracts all this stuff for you. It's like, well, it's fine if that's an option, but it's WebSocket. It's not that complicated. You implement stuff. So I was a little disappointed to see there's like, you should never do this. Wait for someone to write a framework. But whatever. So they have a handler, a WebSocket class as well. They actually do something very interesting, which we'll see, and then I think the JSR actually copied it. So they have a WebSocket interface, but they have nested interfaces for on text message and binary, on frame and on control. So depending on what you want to do, if all you care about is text messages, you just implement on text message, and then that's all you have to really worry about. You don't have to worry about overriding the on binary message, even though you're never going to get it. You still have to override it because it's abstract, for example. There is no Java client in Jetty. All their documentation talks about JavaScript in the browser. So there's nothing really to see there. This is what an example of what their handler would look like. In this case, they're actually doing a select on the sub-protocol that comes in. And they're creating various WebSocket implementations based on which one you wanted to do. It's a little messy, but that's what do WebSocket could look like with sub-protocols. So again, this is their interface. They have the standard on open on close like all the other APIs do. But then these nested interfaces, they actually do like a really nice job, and I wish I'd thought of it, of isolating the bits that you care about. If all you're doing is streaming video, for example, you don't care about text messages, you never have to worry about those methods. Or, for example, if you want a WebSocket that really all it deals with are control frames, and there are a number of specialized frames inside the protocol specification called control frames, and they do a number of things. We've already talked about ping and pong; those are control frames, and there's a handful of others. But if that's all you care about, you just implement on control, and then you just process those, and you can kind of ignore everything else. And then on frame is it's kind of a catch-all. It's like any frame that comes in, I want to get notified, and I'll do stuff with it. You have to jump through a few hoops for that, unfortunately, which makes sense in some cases. But here's one where they actually implement the on frame, and then when it comes in, they have to check, is it a control frame? And so if you want to get that low level, you can. I can't imagine that being terribly useful for most people, but again, it exposes that level of detail if you want. In this case, they're looking for, I think pings is what they're looking for. But yeah, that level of detail is there, and I think that might be the only major API that exposes that sort of detail if you want to build your app that way. Change the page. Which brings us to the JSR. Again, it's still under development, but we are, since I wrote my slides, we went into EDR. What I'm about to show you is still actually pretty close. There are some finer details that may not be quite the same, but I tried to clean it up to make sure it was at least reasonably current. In the JSR, they have client container and server container to abstract away the client and server endpoints. There is a configuration class, which is kind of nice because you can set everything on one centralized configuration and pass it in, rather than trying to hunt down all the different places in the API to change things. And then there's the concept of a message handler. So an endpoint looks like this. There's not a lot to it. This is the very high level version of the endpoint. The same familiar callbacks. So the client container has this interface. It's a very verbose API, but you can set your buffer sizes if you need any of that. You can get all your sessions on your client if you want, and this one actually exposes extensions as part of the API. This part of the API is actually probably the most tenuous, because the protocol itself is not it doesn't feel like as baked, that particular part of it. So the semantics about what it means to handle extensions and how do you build your frames, that part's still kind of up in the air. And extensions are like really low level. There are, if you're familiar at all with looking at wire protocols, there's a chunk in in each packet reserved bits for setting flags, like I'm using this extension or that extension, and then but there's only like 4 bits, so it gets very complicated. If you have too many extensions, there's just not that much space to tell that you're installed there. But that's the client container, and the server container extends the client container and adds just one more publish server. If you've done the Grizzly version, this would be the same as what's it called? Register application, I think, or maybe it's just register. But it's basically inside the server container. It's a way for you to say to your EE container now at this point, this is my application. I need to register it so that you can start processing requests. And we'll see. I think we'll see a little bit of what some of the configuration looks like. So the message handler, this actually. This borrows pretty heavily from Jetty and then adds some interesting stuff. So again, there's a text message handler, binary, async binary, and async text. It's a little weird for me, but I can see where he's going for. But the interesting thing for me is when he added these decoded objects. When it first came up, I was like, do we really want to put this like in the API? And I wasn't sure it was going to work out. But it lets you do some really interesting things. For example, if you're sending JSON back and forth, most of the time when you get into your application, you don't want the JSON bundle necessarily. Sometimes you do, but a lot of times you want to be able to say, I want the Java version of that JSON object. So you can actually register a decoder and implement this interface so that by the time you get notified of this incoming packet frame from the client, it's actually already decoded into some sort of semantically meaningful Java object instead of just like a blob of binary data, for example. But it lets you do that in a very type-safe way because it's all generic and stuff. So it's actually kind of a nice little feature that I had to warm up to. You can do the on-pong if you want. It's curious that no one ever does the ping, but they love the pong. All right, so here's a very simple program, what it would look like. The server container and servlet container, or a client container, they're largely, well, especially the server container, is largely kind of placeholder. It's intended that at some point your EE container, whether it's Glassfish or JBoss or Tomcat really, because they support some of the WebSocket stuff, they would have a meaningful implementation of what a server container is. So there's this kind of a slug method, WebSocket implementation, get me the container, and you get back an interface, whatever it might happen to be. So you set your configuration details. In this case, you're saying I want to serve up anything that starts with /hello. And then the client is very similar. As you can see there at the bottom, I don't know if my mouse shows up. At the bottom you can see new URI WS : blah blah blah. WebSockets does introduce a new URL scheme. WS for WebSocket and WSS for Secure WebSocket. It's like HTTP with 2 less letters. But that's what the URL would look like. And then it connects with the client configuration. So that those will come from whatever your container might happen to be. And then, yeah, this is where all your logic would be. There's a server and a client, and they're both endpoints. There's actually a sub interface called remote endpoint. That is really where most of the interesting stuff is. And the configuration stuff, I hope I added a slide because there's some interesting things in the configuration. And then you connect and publish, just like that. There are annotations that I don't go over them because I would kind of run out of time if I went into it. But you can just annotate your class and say, I want this. Anytime a message comes in, I want that to handle it. And we'll at least see briefly what they are. So this is what a very simple server implementation will look like using the JSR. You get your session from the remote endpoint, as you'll notice, which is just a sub interface from endpoint. And so you get the remote end, whatever that might happen to be, and then you can send stuff. You add your message handler, and in this case, we only care about text stuff. So whenever we get it, we're just going to say, hey, got your message. Thanks a lot. Sorry, my voice is really dry, or my throat's really dry this morning. The client looks very similar. We're only sending text, so that's all we care about. And in this case, we're getting the remote, which is the server end of the world. And this time we're sending OU. So, what's in store? There are annotations where you can hook into various lifecycle events without having to worry about implementing this and subclassing that. Those are pretty new to the spec. Glassfish now has support, I think, for most of these. I don't know that JBoss is working on it. But the Oracle developers have the added advantage of they can kind of work along as things go along. I don't know that JBoss is really that worried about implementing it until we get something that's more fully baked. So we have the annotations, and then, as I mentioned, the encoding APIs, which I do have an example of that. So if you remember, this was the simple server thing. It's just a repeat. There's nothing new there, but I wanted to bring it back for a little reminder. And you can add a custom message receive endpoint is what this one is. And it is, as you can see, it's actually type safe at this point. So when you get on message called to you, you're no longer getting text, you're getting whatever custom message is. And I don't know what custom message is, it doesn't matter. It gets wrapped up, encoded for you, or decoded, I guess, from the wire, and handed off to you. So you get nice compile time checks for your API instead of just dealing with text or byte buffers. And then on an error. And there is a decode exception that comes from that if it doesn't work, it'll throw that. You can do, for example, this implements encoder and decoder. So if you want to encode text as it comes and goes, you can wrap it up in kind of whatever you want. There is a method called will decode, which is an awkward name, but much like the is application request, you implement this method and just check to make sure, in this case, that it starts with custom message before you decode it and coming back out. What's coming up in the API is we're still talking about how to support extensions and how to expose that in a sane way. Not entirely sure what that'll look like, but it does lead to custom framing, and that once you get down to the point of changing your framing, it could kind of mean anything. If you want to encrypt it before it goes out, or if you want to, I don't know, bit shift everything in there. So, like I said, it's already in the API. The discussions are pretty light on it because we're not entirely sure what's going on. But we are looking, we'll have to look eventually at multiplexing. I'm not sure if it'll make it in EE7, the multiplexing part of the API, because it's not part of the wire protocol yet. And it is the IETF that's discussing multiplexing, and there's no telling how long that will take. So it's unlikely that we'll commit to getting multiplexing in the 1.0 for WebSockets. And then, of course, compression. The discussions going on in the working group for that is to be able to expose custom compression options. So if you prefer, gzip over pack 200 or whatever, you just plug it in, use whatever thing works for you. That might make its way into the API because that is active, under a very active discussion with the working group, and I think it's pretty close to being done. So just very briefly, I want to touch on like what future does WebSockets have? Because one of the concerns that I have, there are now broader discussions between Speedy and Microsoft has their own HTTP 2.0 speed mobility, which will hopefully have a shorter name. But these are competing looks at if we're going to really replace HTTP in general, what would it look like? WebSockets works on top of HTTP and everything is golden and it's actually kind of nice. These are looks at deeper looks at like fundamentally changing what the wire protocol looks like. Speedy is actually implemented. I think Greg was saying like 40% of all web servers support Speedy now. If you use Google Chrome to look at Gmail, you're using Speedy. You're not using HTTP. But you don't know that because they hide the URL for you. But there's also HTTP 2.0, and there's actually two different versions of what that should look like. Microsoft has their own. The Speedy camp has their view of it, and there's yet another group that has their own whatever. These are likely years away because these discussions take time and because everyone wants to have a say. So as far as WebSockets go, it's here now, so you can start doing a lot of this really advanced applications on top of it now without worrying too much. There are actually examples of running WebSockets on top of Speedy, which feels a little redundant to me, but it does let you offload things like TLS, negotiation, and encryption and whatnot. Offload that to Speedy, and then you can just piggyback on top of that. We'll see how that goes, but I have a feeling those will be years away because that's a pretty contentious discussion. So if you want to learn more, the actual RFC is there at the top. If you like reading specifications, it's actually not bad. The framing diagram is actually kind of interesting because there's a lot going on in a very small space. So if you like that sort of thing, it's there. That's the link for the JSR is there. We are in early draft review. You can download the Java docs, and there's a specification PDF if you want to read through it, and it kind of explains in more detail about what's going on. Websocket.org is the W3C site for the JavaScript part of the world, and they'll talk about what some of the API there looks like. The last three are, Grizzly, Tomcat, and Eclipse. If you want to look at Jetty, if you want to look specifically at those documentation of those websites. There's a lot more examples there about what's going on, but they all work today. And I was going to mention something else, but I forget what it is. I will say just briefly. I want to kind of restate because until this shows up actually in containers, you're still left to have to re-implement it for whichever container you're in. You should actually really take a look at Atmosphere. I was hoping to have some example slides, but I just ran out of time. Atmosphere will really abstract most of that away for you. And it has the nice benefit of if you're on a browser that doesn't have WebSocket support, which is unlikely these days, but it happens, it'll actually fall back to Comet for you transparently, and you'll never know the difference. So it will take a lot of the pain out of that, and at least until the JSR actually shows up on all the containers you care about. That is an option. But that is all I have. I hope I didn't run too short. I tend to talk fast when I'm dry and thirsty. But I'm happy to take any questions you might have. And I will just say, because my company is paying for me to be here, we are hiring, so if you wanted to live in New York, let me know, because we are literally hiring for everything. But I don't want to make it into a sales pitch. So, anyways, that's all I have. Does anyone have any questions I can answer? Sure.
When do you expect the DSR to be finalized?
It will ship with EE7, which is, I think, targeted for next summer. So. When I submitted this talk, the timeline for completion was actually supposed to have been this fall. So I was hoping to have a lot more concrete things to say, but then they shifted all the schedules back. Like, well, we'll deal with what we've got now. And it's actually pretty, the API is actually looking pretty good. There are a number of things I see now in the spec that I kind of wish I'd thought of when I was writing Grizzly. But I didn't, and then the API will fix it. But anyways. Still a lingering malaise, like, I don't know what's up. Okay, so what he's asking about is like, what are the security concerns? And there was a guy who wrote a paper, and it made a huge stink, and both Firefox and I think Chrome said, oh, we're out until you fix this, we're just not going to do it. So it kind of sidetracked the whole evolution of the spec for a while. But essentially what the problem is, under certain contrived situations, the original connect goes through, and it looks like HTTP, and everything is fine. But if you're going through a proxy, for example, the proxy takes everything, comes in, and hands it off. And normally that's fine, but a malicious developer could craft a frame message that looks like an HTTP request. So they get through fine because it's just, just hey, forward me on. And now once they're inside the proxy, they can send a frame and start redirecting traffic somewhere else. And they can basically hijack the session because now they're in the firewall. So there was some concerns like, well, what if they do that? What do we do? So that's when if you hear about masking in the WebSocket specification, that's what that is. It's basically, it's a random bit set. I forget how wide, I think it's like 16 bits. But for every byte that comes through, they mask it with this mask, and then they rotate it through. And it's secure in that the browsers restrict client code from doing that. So I can create whatever I want. I can upload a virus that infects your whatever from my JavaScript, but by the time I hand it off to the browser, it's going to mask everything so it shows up as a random jumble of bits. And at that point, the proxy server will just take, I don't know what that is, so I'm just going to keep handing it off, and I'm not going to worry about it. But it prevents people from creating malicious packets that then hijack your network infrastructure. There was a very long, like you said, there was a very long, prolonged public discussion about it. I think most people were like, it's not really a big deal. Apparently even his test case was a little bit contrived to make his point. But it was one of those things where everyone was freaked out about it enough that the working group decided it had to address it. So if you hear people complaining about complexity in the spec, that's one of the things, because masking, it's a little involved. But for developers, it's actually transparent. It's a little bit like working with SSL. No one ever creates a packet and then manually encrypts all the bits before handing it off. You just hand it off and the infrastructure takes care of it. So it's there, but it never really affects what you're doing. So, does that answer your question?
Yes, yes.
Perfect.
How does WebSocket work in a cluster?
Well, it's a little bit like how do sessions work. It is an end-to-point persistent connection. So once it enters the cluster and one of the nodes in the network handles it, it's probably going to be sticky to that one node because it's not like you can migrate connections around the cluster. But there are options for that as well. There is, I believe Kazing has an option for this, where you actually put an intermediary inside your network infrastructure. So the connection comes in and it hits here, and then essentially you just proxy it inside your network. And at that point, the connection comes in and you can say, all right, I'm going to go to you this time, and I'm going to go up here, it's going to go back over here. And you can do that kind of round robin yourself or whatever it might happen to be. But the protocol itself doesn't address that because It's like how do you migrate connections around, you know? But anyone else?
Can you talk about the tooling for debugging WebSockets and stuff? Because like mostly you can, if you in regular HTTP you can see headers, see stuff. But it's not HTTP anymore. So
Right. That's actually a great question, and I was chuckling earlier in the week. Was like everyone says, "Oh, that's a great question," but it actually gets really tricky because when I first started developing the Grizzly implementation, there was no masking. So I used a tool called ngrep, which if you haven't discovered ngrep yet, it is fantastic. It's a network grep. You can give it, say, I want to track everything on this port that happens to go to this particular host, and then everything goes out and you can kind of see. So when I started developing it, I could see the frames come by and I can see here's these bits and that and there's my payload and it's like, that's not quite what I wanted, and I can tweak it and fix things. And then masking came along. And it's a little bit like trying to debug an SSL connection at that point, because you normally had, hey, hello world, but now when you see it, it's like this random jumble of, some of them aren't even ASCII characters anymore because it's all masked. And it gets very, very tricky. I never had like a great solution for it. For me personally, I would also have to put a little bit debug in before masking was applied because I was in the source code and I can do that. If you're looking at on the wire stuff, it gets very tricky because the masking obscures a lot of it. But but that's just the payload. If you're looking at, there's all sorts of header information. There's various bits and masks and stuff that you can actually look at that, and that stuff is all in the clear. So if you understand the wire protocol, you can look at that and kind of make sense of it. But your payload is pretty much a black box unless you want to like manually unmask everything on the fly like that. It is a little awkward. So, anyone else? Yes.
How does it get unmasked? Is it going to be unmasked on the server side or
The browser does it. Masking is weird in that it's one direction. The spec group wasn't terribly concerned about traffic coming back out through the proxy because those proxies, when it comes out of the network back to the other endpoint, the proxies don't inspect that. They just kind of hand it off. But coming into the network, the proxies, all the intermediaries, they actually inspect the data coming in because it might be like, oh, I need to forward this or forward to that. So masking is only one direction. And those mask bits are determined by the browser in this case, and it's actually included when you send the packet. Those mask values are actually included on the other end, so the server can then use that same mask to unmask it on the backside. And where that becomes more secure is that client code is never exposed to what that mask value is. They have zero say and zero visibility into what that mask is going to be. So in your JavaScript code, you would just say WebSocket.send, and you'd hand it a big chunk of text, and then the browser will take care of masking that, and it's completely outside of the control of some a hacker won't be able to get at that particular information to craft specialized attack packets. Does that make sense? Anything else? Anyone? One of the goals of WebSockets was to piggyback on top of HTTP. So when the initial request comes in, as far as anyone's concerned, it's just HTTP, and it literally is. You'll have your get/HTTP 1.1, but what's different is there's an upgrade header, and there's another. I forget. It's actually a pair of headers on the initial request. So when it comes in, as far as your firewall is concerned and your routers and whatnot, it's just an HTTP request. And then what happens is when the server comes in and it sees this request, it returns with a 101, which is basically telling the client, okay, I heard your request to upgrade this thing. I agree. Let's do this. And then at that point, both ends kind of switch over to sending this framed data back and forth. So your firewall doesn't even know the difference. And then once that connection is upgraded, it's just sending bits back and forth, and it's a little bit like an SSL connection at that point. It doesn't really, your firewall typically doesn't inspect each packet coming in. Once it's been negotiated and approved on the other side, it just passes the bits back and forth. And that's how it gets to the firewall. And that's actually one of the perks of WebSockets, is that you can actually connect through other parts of the network without having to open more ports on your firewall. Because most IT shops are like, I'm not going to open another port because they all get freaked out about it. So yeah. Does that make sense?
The main problem with the firewall in this case is that the proxy server will cache some of the information. And some of the faults, like Encoding, for example, they recommend use like WebSocket Secure. You have like full SSL, and the proxy server would not be cache actual bits. And at this point, you can do just point-to-point. It's like a VPN. So
Right.
absolutely works seamlessly for each and every proxy server. If it's like active or passive mode for checking all this information.
Right.
So as an answer for your question, you should try like use secure WebSocket connection. So,
Yeah.
And at this point, you should not worry about any proxy servers at all.
Yeah. Yeah, and that's a great point. You can actually, there are certain intermediaries that, after, like if a connection goes on too long, they'll look at it as like, what's going on here? It's been around too long, so I'm just going to kill it. Because most HTTP requests, of course, you're in and you're out and you're kind of done. And so when they see one this thing's been open for 4 hours, I don't know what's going on, so I'm just going to kill it. You can actually use the WSS protocol, which basically is an SSL encryption. And most intermediaries, they'll look at it and say, I know it's been open for a week and a half, but it's secure, so I'm just going to leave that one alone. You might have to do that if you find yourself on a network that has intermediaries that just randomly close things on you. So, yes, sir.
How many WebSocket connections that you can open simultaneously from a client?
Well, it depends. On the client, I don't think there's any hard, like, for example, like with HTTP, most browsers enforce, like 2 connections or 5 or whatever it happen to be. That's mostly kind of a gentleman's agreement on the client side. There's absolutely no discussion anywhere that I'm aware of about such limits for WebSockets. So you could potentially open up boatloads of them coming out. But they are much lighter weight in a lot of ways than HTTP, so that's kind of okay. But I have a feeling once multiplexing shows up that we'll start seeing kind of more formal specifications of like how many times should we actually do this from one user agent. Does that make sense? Did I answer your question?
If the socket is built on top of the JDB, then still the gentleman agreements remain.
You might still be subject to that, and that will vary depending on what your browser is. I haven't run into an issue of that, but then I really haven't tried to open up 100 connections from one web page either. So.
The reason I'm asking is, example, you have a portal, right? Portal page, and you have multiple applications, and if you have using the socket, then you'll be bound to.
Right, you might try to open up a dozen of them, and your browser will say, "Wait a second, there." That might happen, and at that point, you'd want to look at something to multiplex through that, and at least until the protocol supports it. And at that point, you might want to use something like Atmosphere, which has multiplexing built on top of it. It does its own multiplexing logic to route requests back through. So you might need something like that. So, but on the server side, I was talking to Greg Wilkins last night, and he would run some numbers comparing Comet D and WebSockets. And the number of concurrent connections on WebSockets was like 10 times higher than under WebSockets. And the latency was an order of magnitude or 2 less than Comet. So if you need to open a whole lot of WebSocket connections on the server side, you're probably going to be okay because it does really, really well on the server side. But it depends on what your client is. Does that help? All right, I think we have 5 minutes before they kick us out. Any other questions? No? Okay, well that's it. Thank you so much.